You've probably used a chatbot or an AI writing assistant and had that moment, that little bit of wonder where it feels like you're talking to something that actually thinks. But what's really happening under the hood? Well, today we're going to pull back the curtain and demystify large language models, showing you exactly how they really work.
So let's just dive right into the central question, right? How does an AI actually write? I mean, it doesn't have a brain, it doesn't have memories or experiences, so how in the world can it spit out text that sounds so incredibly human? That's the big mystery we're going to unravel together.
All right, here's our game plan. First, we'll cover the basics. What are LLMs? Then we'll get into how they learn from patterns and predict the next word. After that, we'll tackle that huge question of whether they truly understand anything, look at them as tools, and finally, talk about our own role in this new AI world.
Okay, let's start at the very beginning. What exactly is a large language model?
So at its core, a large language model, or LLM for short, is a special kind of artificial intelligence. Its entire job, its whole purpose, is to understand and create human-like language. And the way it does that is by learning statistical patterns from just massive amounts of text.
And this brings us to what is maybe the single most important idea to grasp in this whole thing. LLMs learn patterns. They do not understand meaning. See, they run on probability, not on conscious thought. An LLM doesn't know what a cat is. It has no idea about a furry little animal that likes to nap. It just knows statistically that the word cat is very likely to show up near words like purr, meow, and kitten. It's all just math.
And really, that's why they were built. Human language is it's a mess, right? It's complex, it's unpredictable, full of nuance and inside jokes. LLMs are our best attempt so far at wrangling that complexity by using raw computing power to map out all the statistical connections between words and ideas from a giant library of text.
Okay, so how does this learning actually happen? That brings us to our next part, how the machine is taught.
The whole training process kicks off with a truly mind-boggling amount of raw data. We're talking about a digital library that includes huge chunks of the internet, countless books, articles, basically any text we can get our hands on. This is the food that the model eats to learn about our world. And all that learning gets stored in what's called a neural network, which you can kind of think of as the model's brain. This brain is made up of billions, and I mean billions, of connections called parameters. Imagine each parameter is like a tiny little dial. During training, each one gets tuned just right to store a tiny piece of information, like how strongly the word coffee is connected to morning. With billions of these dials, the model can store an incredible web of patterns.
So to put it all together, the process is pretty simple on the surface. First, the model just sucks in all that text data. Then it starts analyzing all the relationships between the words. From there, it learns the probabilities, the odds, of which words tend to show up together. And finally, it stores all those patterns in those billions of little parameter dials we just talked about, ready to go.
Okay, so the model is trained. It's full of patterns. Now what? Well, this gets us to the real engine of how it all works, predicting the next token.
Now, before we go on, we need to know what a token is. An LLM doesn't really see words like we do. It sees these things called tokens. A token is its basic building block. It might be a whole word, like happy, or just part of a word, like the ing in running, or even just a comma. Breaking language down into these little pieces makes it way easier for a computer to handle statistically.
And that brings us to what the LLM is actually doing at every single moment. Its one and only job is to calculate the probability of what the very next token should be. That's it. It's like the most powerful, most sophisticated autocomplete you've ever imagined. You type, "the sun rises in the," and based on all that training, it calculates an extremely high probability for the token east and a near zero probability for car. It just does that over and over, one token at a time, to build whole sentences, paragraphs, and essays.
This prediction engine is so good, it's so powerful, that it creates this really compelling illusion, which brings us to our next big idea: intelligence without understanding.
Because these models can generate such coherent, fluid responses, it's only natural that they seem intelligent. I mean, when an AI writes a beautiful poem or explains quantum physics, we can't help but feel like it gets it. But this is where we have to remember, it doesn't. It's just an incredibly advanced pattern-matching machine, spitting out the most probable sequence of tokens it learned from all that data.
This slide really just lays it all out. When we humans understand something, we're using context, intent, meaning, beliefs. We have consciousness. The LLM
It's all data and probability, prediction and statistics. It's calculation. What feels like intelligence to us is just a masterful, lightning-fast calculation of what should come next. If you remember just one thing from all of this, let it be this difference right here.
So if they don't really understand, what are they actually good for? Let's bring this all back down to earth and talk about them as tools, looking at their very real strengths and limitations. Because they are absolute masters of language patterns, LLMs are fantastic at certain tasks. They are amazing at generating text, anything from a quick email to a creative story. They can take a huge, long document and summarize it down to the key points. They can answer questions by finding relevant patterns in their data. And they're getting scarily good at translating between languages.
But, and this is a really big but, those strengths have some serious limitations. Because they don't know what's true or false, they can just make stuff up and sound totally convincing while they do it. These are often called hallucinations. They can also reflect all the biases, good and bad, that were in the data they were trained on. And maybe the trickiest part, they always sound confident even when they're completely wrong. And that is why human oversight isn't just a good idea, it's absolutely essential.
And chances are you're already running into these tools all the time. They're the engine behind the chatbots you talk to online. They're being built into search engines to give you quick summary answers. They're the core of those writing tools that help you with grammar and style. And businesses are using them for things like automated customer support. They're everywhere.
All of this brings us to a final and honestly, the most crucial point. What is our role in all of this? How do we use these tools responsibly?
When it all comes down to it, we have to see these models for exactly what they are. They are incredibly powerful tools, but they are not independent thinkers. They don't have intentions. They don't make decisions. They are just sophisticated instruments that do what we tell them to do. And that means the responsibility lands squarely back on us. We're the ones who have to guide them with good prompts. We're the ones who have to verify what they tell us and check the facts. And ultimately, we are the ones who have to interpret their output with our own critical thinking.
So, we've seen that these incredible technologies aren't magic. They're just very, very complex tools, built on math and probability, designed to find and repeat patterns in our own language. They don't think, they predict. And so that leaves us with one final important question to think about. Now that you know how they really work, how are you going to use them responsibly?